All right, everybody, this is 7.3, solving system applications. So basically, we're doing the same as we did for 7.1 and 2, but using word problems, okay? So let's just get right into it. So solving by graphing. So this was like 7.2. So if you need to, you can always refer to that, watch the video for that. But basically what we're trying to do is we're going to graph both of these equations and see where they intersect. Okay, so let's start with the linear equation. So again, well, maybe I should read the instructions. That'd probably be good. So the function p of x equals negative x squared plus 6x models the profit made. So that's p, right, in hundreds of dollars. For selling X cases of sports drink. So if you sell a lot of sports drinks, then you're going to have more profit. So that's kind of like the relationship here for that equation. It says the function c of x equals x models the cost in hundreds of dollars for producing X cases of sports drink. So yeah, it's great to sell product, but it also costs money to make it. So the cost is that second equation. So part A says graph both functions. All right, so just a quick reminder is that this is a line. It's a linear equation, like y equals mx plus b, or is that form, okay? So for this example, it's y equals 1x plus 0. So again, this is your y-intercept. And then our slope is 1 over 1. So that's our m. And we're going to plot that. So y-intercept is 0. Got that. And then rise over run is 1 over 1. So this is just a straight line, constant slope. Connect your dots. Okay, so this is, again, the cost to produce. So the more that you produce, the more it costs. Okay, our second equation is a linear equation. Again, you are welcome to use your graphing calculator to do that if you'd like. Again, we could type it into the your graphing calculator and come up with your vertex and plot that vertex, and then use the growth pattern. I'm just going to do it by hand. So again, if you're trying to find the vertex, it's an x and it's a y. X is always negative b over 2a, at least for standard form, which all of our equations have been in for this unit. Again, a is negative 1 and b is 6. If you wanted it, you would know that c is 0. Okay, so that's the y-intercept for the parabola. So we'll plug that in. We got negative b, which is 6, over 2 times a, which is negative 1. So we end up getting 3. Again, if that's your x for your vertex, so it's 3 comma something. If you need to find that something, we'll just plug it into our equation. Okay, and again, it has to be the quadratic. It has to be the equation you used for your x for this. So we'll do negative, and then parentheses 3 squared, plus 6 times 3. And again, this will be negative 9 plus 18, which is 9. So this is your vertex, 3 comma 9. So we'll plot that. And then the growth pattern, so again, a is negative 1, so it's going to go down 1, 3, 5. So over 1, down 1, over 1, down 3, over 1, down 5 on both sides. Connect those dots, make it look like a parabola. And now let's answer the question for B. So it says, how many cases of drink must the company sell for the profit to be equal the cost? Okay, so this has two x-intercepts, or sorry, two intersections, so it crosses it twice. One would be if you sold 0 cases. So if you sold 0 cases and you made no sports drink at all, obviously it would be this, like, if that makes any sense. So if you don't make any product, then you didn't have to spend anything. So that'd be $0. If you don't have any product, then you can't sell it. So you earned $0. So that would be one of the cases, is where you sold 0 cases. Okay? So the profit equals the cost. The other would be at 5. So if you sold or sell, I should say sell, I don't know, whatever, 0 cases or 5 cases. So if you sell 5 cases and you produce 5 cases, then you also broke even. Okay? So those would be the two options of things that could happen. Really, probably the second example is probably the one that's probably more viable, just because who would go to the work of making the company and all that stuff and then not making anything so that you can't sell anything? So that doesn't make a whole lot of sense. Okay? Anyways, so like this is an example where we have an answer that's not an ordered pair. Okay? All right, let's go on to solving by substitution. Okay? So 2 art exhibits open at the local museum on the same day. The attendance for one can be modeled by this equation, y equals x squared minus 4x plus 35, while the other can be modeled by this equation, y equals 7x plus 5, where x represents days and y represents the number of people who attended. Determine the number of days since opening that the attendance at each exhibit is the same. So they want us to find the intersections. So what are the intersections, and what do the intersections represent in the context of the problem? Okay, so again, let's first solve the system. So again, we set them equal to each other. Again, if you need to, you can go to 7.1 if you need extra examples of that. So 7x plus 5, we want it to be equal to x squared minus 4x plus 35. Okay, so we'll get everything on one side. So subtract 7x, subtract 5. So we get 0 equals x squared minus 11x plus 30. So a is 1, so that's going to be nice. We can use the shortcut. We need to figure out what multiplies to 30 and could add to negative 11. So again, if you're ever stuck, you can always write down factor pairs. So 1 and 30, 2 and 15, 3 and 10, 4 doesn't work, but 5 and 6. So which of those could give us 11? I think it's going to have to be 5 and 6, but both negative. So our equation in intercept form would be x minus 5 and x would minus 6. So then again, we find our two solutions, our two x values that would make the equation be equal to 0. So this would have to be x equals 5 and x equals 6. So again, our answers would be 5 comma something and 6 comma something. If you have an x and you need to find a y, then we can plug it into one of the two equations. So I'm going to use the easier one, the y equals 7x plus 5. So we'd get y equals 7 times x. So for this example, we'll do x is 5 plus 5. So that should be 40. and then we'll do it when x is 6. Okay. And again, you're welcome to use your calculator if you need to. So 6 times 7 is 42 plus 5 is 47. So then our two solutions here would be 5, 40 and 6, 47. So let's answer, what do those represent? Okay, so again, it says here that x represents days and y represents the number of people that attended. So what does this mean in the context of the problem? This is saying on day 5, both exhibits have 40 people attending, or attending, I don't know, something like that. And then for our second intersection, again, it would be on day 6, both exhibits have 70 or 47 people attending. Okay. So any other days, they won't be attending, the same amount of people would be in both. So these are the only time where both exhibits have the same number of people attending.